Next topic is division and the algorithms that are associated with the operation. So we're just gonna work as we go and I'll explain a few things. So we'll do 826 divided by 7. So at first, division, we already talked about how this operation relates to subtraction, right? So division is just repeated subtraction. And so when the students are first developing, especially in elementary, when they're first developing the sense of division, um, they probably won't be able to do the long division the way we've been taught. So, and that's okay because it's all part of the progression, right? So here, what they could do is see how many times 7 goes into 826, and that may take a while to get to, or if for the students who are good at multiplication already, may take shorter, right? So part of it is you could just have them play around with it for a while, or so one way to do it would be how many times does 7 go into 826? So I can just first look at how many hundreds of sevens I could put in. So if I put 100 sevens, then I have 700, right? And if I subtract that out, now I only need to worry about 126 more. And I still need to figure out how many sevens I can put into 126. So I can put in 10 sevens. If I have 10 sevens, that's 70. And then once again, I can subtract that out. So I get 56. And then some students might divide or subtract by 7 multiple times to get this solution. Or if they're more familiar with multiplication, we need 8 more 7s to get 56. And then finally, we're done with the division, right? But we still have to find out how many total 7s we had to put in to get to 826. So if we add all this up, we get 118 sevens. So in other words, it takes 118 units of 7 to get to 826. And so to check our operation, you could do 118 times, whoops, it's not showing up, times 7 to make sure you get 826. And there are several different algorithms that you could start off with. The other one that our textbook went through is kind of going above and below. So how many, instead of having it on the side, going above it. So I need 100 sevens to get 700, and I have 126 left after. And then I need 10 sevens to get 70, and then I have 56 left. And then finally 8 sevens to get 56, and then I have no more left to put into 7. And then after that, you can add these up. So the process is just saying whether you go from up to down or down to up and whatnot. But eventually you want to get to the most efficient algorithm, which is not writing out the place values, but just knowing where they are. So instead of doing 7 times 100, I know to write 1 because that's in the hundreds place, and just do 7, subtract that out. Now I have 12, right? So dropping down 1 at a time and allotting that place value to be blank. And so I can fit 1 into that. So just keep in mind this operation means 10 sevens, and that's a 70 because we haven't gotten to the ones yet. And we have 5 left, and then we drop down the 6. And finally, we can get 8 times 56. So these are all progressions, and even then, we might have some things before, right? So using the grouping with the units, longs, and flats, and blocks, we could start off by grouping things into sevens and how many of those we could do. So just keep that in mind, that there's a lot of things that come before your students are going to develop that notion of the algorithm and the most efficient way But have them explore, have them figure it out for themselves, have them try different things so that they get a concrete understanding of what they're doing instead of just doing it because that's the way they've been taught, which won't last much. So it's always better to understand things than to just know how to do the operation.